Welcome back, class. Before we get started on this last week of classes, well, last 4 sessions anyway, I do want to address something. Danielle wrote me an email, and I may have made a mistake in one of my conclusions for our examples. I don't know which one, but let me just clarify. Uh, if you do a t-test and you get a t-value that's greater than the critical value, right? So our critical values were 2 point something something something, right? 2 point something something something. So if we get an observed value that's greater than that, then we report that, and the p-value would be p less than 0.05, right? We're saying that the probability of the null hypothesis is less than 5%, and so we reject the null, okay? If we end up having a t-value that does not go beyond our critical, right? That doesn't go beyond that 2.22 something or whatever, then we fail to reject the null. And that p-value then is greater than 0.05, okay? Let's remember what the p-value tells us, and that will guide you. So you don't have to memorize stuff. I never want people to memorize things because this all really makes sense. It's just the symbols that we use. If we reject the null, we're saying that the probability of the null happening is less than 5%. If we fail to reject the null, we're saying that the probability of the null is greater than 5%. And so we don't reject it, okay? So anyway, that's just a guide to help you, and I may have made a mistake. It's easy to make mistakes, folks. That's just a fact, and so that's why you have to be careful. And the more you understand the concepts, the less likely you are to make a mistake, okay? All right, so I want to really switch gears now from looking at differences, right? We looked at differences. I made a big deal about that in the last videotape. We're looking at z-scores are looking at difference over variability, t-test differences over variability, and then finally analysis of variance, difference between the groups. We're going to use those within groups variability. If you're looking for a difference between groups, then you use a t-test or analysis of variance if there's more than 2 groups, right? But there are other research questions that we can be interested in, and let me set one up for you, and I hope it will be illustrative of the difference in the question that we ask about these data, okay? So let's suppose that I'm interested in studying whether or not there's a relationship between alcohol intake and students' grades, all right? So I might be concerned that if students drink too much alcohol, that's going to be associated with their grades in school. So I would do this not as an experiment. I can't really do this as an experiment, right? I can't have one group in the get drunk all the time condition and another group in the sober all the time condition. That would be kind of unethical. And so, but I might be able to address this question of whether or not there's a relationship by collecting data from students. So what I'm going to do is I'm going to ask a bunch of students, how much do you drink, let's say per week? How many ounces of alcohol per week? And then I'm going to get their GPA, okay? And I'm going to see if there's a relationship here. So let's look at some data. Normally, if I was going to do this as a survey research project, I would have hundreds, hopefully, hundreds of respondents. We're going to make our data much simpler than that because we're going to do some calculations by hand. But what we're talking about today can be used if you have, 200 or 500 or 1,276 respondents to your survey. You're going to do the same procedure, okay? Just like a t-test. I mean, t-test can be done with small groups, but it can also be done with larger groups as well, okay? So let's look at the data here. I made up these data, but for our purposes for analysis here. So we have alcohol intake, and let's say that this is ounces of alcohol per week. So 40 ounces of alcohol per week. And then I have GPA as well, okay? Now for this kind of research, these numbers in a way are connected, right? So this is subject number one, or student number one, drinks 40 ounces of alcohol per week and has a GPA, oh boy, 0.8. Oops. Okay. And then student 2 drinks 4 ounces of alcohol per week and has a GPA of 3.6. And so on and so forth. Okay. We're going to keep going down. So these are paired numbers from the same subject. I mean, it wouldn't make sense if it wasn't from the same person. Okay? And we might call this the X variable here and this the Y variable. And I want to emphasize the question that we're asking here, the research question that we're asking, I am absolutely not asking if there's a difference between the average amount of alcohol and the average GPA. That is, it wouldn't be interesting. It doesn't even make any sense, right? It's like comparing aardvarks and airplanes. What I want to know is there a relationship between these two? Is there a relationship between these two? What do I mean by that? Well, do people who drink more alcohol, does it look like they have lower grades than students who drink less alcohol? Okay? I'm looking at a correlation here, okay? A co-relationship. Correlation, all right? I'm asking whether there's a correlation, where there's a relationship between these two variables, right? There's two variables. So it's a co-relationship. But the word got a little bit messed up in my mind. It's called correlation, okay? Co-relationship. And let's look at the numbers. And if we were in the classroom, I would say, what do you think? Does it look like there's a general relationship here? Does it look like people who are drinking more alcohol have lower GPA, higher GPA, or don't you think there's any relationship between the two? Well, it sort of looks like there's a little bit of a relationship here, right? The person that drinks the most alcohol has the lowest GPA, and some of the people that are drinking the least have higher GPAs, and then there's something in the middle, okay? So the first thing that I would ask you to do when you have data that looks like this, where you're asking whether there's a correlation, right? I'm not asking whether there's a difference. I mean, all of these numbers are under 4. There's several of these that are double digits. Could we do a t-test here? We could. I'm just not sure what it would mean, right? What would it mean if there's an average, a difference between the average alcohol intake and the average GPA? It doesn't make much sense, okay? By the way, this is one of the most common questions that people asked me when I was in graduate school. I would help lots of people with statistics. And they would come to me with 2 groups like this. And they said, oh, I have 2 groups. I should do a t-test, right? And I said, well, a t-test is done if you want to know if there's a difference between the 2 averages. In this case, we're asking really a different question. And that is there a relationship between the two? Now, this is one of the frustrating things as a teacher because people are very loose with vocabulary, okay? When I say, is there a relationship between these two, that means something different than if I say, is there a difference between these two groups? Okay. Let's do this. First thing I want you to do here, if you're looking for a relationship, let's make what's called a scatter plot. Okay. Let's make a scatter plot. Some people call this a scattergram. What I'm going to do here is I'm going to make a graph, sort of. I'll put my alcohol intake on the bottom. So we go from what, 0 to 40. So let's do this. 10, 20, 30, 40. Okay? That would be 5, 15, 25, 35. Okay? That's my x variable. And then on the y-axis, I'm going to put GPA. And of course, let's do this. It goes 1, 2, 3, 4. Put our halves in there. Okay. So this is what a scatter plot is. Now each student here, each respondent has an x value and a y value, right? These are the Cartesian coordinates. Yep. Okay. Probably a neuron or two firing in your brain because you remember from high school Cartesian coordinates, an x value and a y value, right? So let's take our time and do the graph here. Student number 1, 40 ounces of alcohol, and they have a GPA of 0.8. Okay, so that point represents that student. Now this student, 4 ounces of alcohol per week, 3.6. So here's 4 ounces of alcohol, and here's 3.6. All right? And we'll put the rest in, 0 and 3.1, okay, and 23 and 2.7. Doesn't have to be perfect, 12 and 3. 6 and 3.8, that's way up here, okay, and 31 and 1.5, and 24 and 3.3, and 9 and 3.2, okay, so that's up here, all right, so that's our scatter plot, and I always have people do a scatter plot because, I mean, I use a small data set like this, and I'm hoping that when I ask the question, does it look like there's a relationship? I'm hoping that you could kind of see that. You know, I'm exaggerating the data so you can see that. Another thing, if you had 500 respondents for your survey, it would be difficult to kind of eyeball to see, you know, what the relationship is. Typically, you can do that with an Excel spreadsheet on your computer and do a scatter plot of those points. And what we see from the scatter plot here is, yeah, I mean, let's look at this. Let's look at this trend here. It looks like people that are drinking more alcohol have lower GPA, right? People that are out here in alcohol are down here in GPA. If we look at people drinking less alcohol, we see that they're sort of clustered up in here, okay? So we see this general relationship here. There are differences in terms of, you know, this person that's drinking 24 has a 3.3. That's not bad, okay? But in general, we see this relationship where as x goes up, y goes down, okay? Or we could say for lower x values, we see higher y values, okay? And if you remember from algebra or some other math course that you've taken, this would be referred to as a negative slope. This is a negative slope, okay? If we were sort of try to do a best fit straight line here, we would see that it's a negative slope. And so this kind of relationship here, this kind of correlation, is called a negative correlation. It's called a negative correlation because it has a negative slope, okay? If I was looking at, let's do this, if we're at a ballpark, let's say, a baseball park, and if we looked at temperature and number of beer sales, we might find that as the temperature goes up, our beer sales go up as well, okay? So as X goes up, Y goes up, or as X goes down, Y goes down. When we have a relationship like that, it's called a positive correlation, because if we were to plot it on a scatter plot, we would see a positive correlation, okay, a positive slope. This is a negative slope, so we call it a negative correlation. It does not mean there isn't a correlation, and in fact, this looks like quite a strong correlation. The terminology, negative correlation, means that we're talking about a negative slope. As X goes up, Y goes down, okay? Or as X goes down, Y goes up. So if they're changing in opposite directions, we call it a negative correlation. If they change in the same direction, we call that a positive correlation, okay? So that's what we're asking with this statistic. It's really quite different than a t-test. T-test is used to look at it to see if there's a difference between the averages, right? M1 minus M2. This is a completely different question. This is asking, is there a relationship between these two variables? As one variable goes up, does the other variable tend to change in one direction or another? Okay? In this example, it looks like as one variable goes up, the other variable goes down. Okay? That's called a negative correlation. Okay? Now, we're going to do a statistical test for this correlation. Okay? If you want to look at the relationship between two variables, use a correlation. If you want to look at the differences between two groups, then use a t-test. I actually got a bunch of free beer in graduate school because my lab mates and other people in the program would come to me and they would want to know what they should do, a t-test or a correlation test, and depending on the question that they're asking. Okay, this typically comes from non-experimental. This typically is done with survey research. So the test that we're going to do is called the Pearsons R. It's called the Pearsons R. Okay, so we had a Z, we had a T, we had an F for ANOVA, right, for analysis of variance, and now we have another lettered test. This is called the Pearsons R test, okay? And it's pretty straightforward, I think. Here's the formula, and of course you'll be given the formula on the exam, and once you're out of the exam, you use your stats book. I mean, when you go to graduate school, by the way, I would highly recommend that you keep your statistics book. If you're going to go on in school, keep this stats book. It's the one that you learn from, okay? Because if you're going to be a professional, you're going to use stats, and it will come in handy, okay? Here's the formula. Let's take a look at it. This is the sum of squares for the x values. So if we go back here, what we're going to do is we're going to get our sum of squares for these, okay? Multiply that by the sum of squares for the y values. I have a subscript of a y there. So we're just going to go back here. Here are the y values, okay? So we'll get the sum of squares for these numbers. We're going to get the sum of squares for these numbers. Yep. Okay. Multiply those together, then take the square root. So far so good. I know that you guys can do sum of squares, okay? We have a new term up here, and that is SP. This is called the sum of the products rather than the sum of the squares. Okay, this is called the sum of the products. And I'll show you what the formula is for SP, and it's related to SS. It's related to sum of squares. It's different, but it's related. So remember our sum of squares formula, okay? And we'll be using that to get our sum of squares for that group. Remember when we do a square, that is a shorthand notation. What is that telling us? If I say x squared, what am I saying? X times x, right? So what I'm going to do here is and you don't need to know how to do this. I'm just showing you to make sense out of the sum of products. I'm just showing you where it comes from because I think it's kind of interesting, but you know, I'm a nerd. Here is the sum of x squared. That means we're the sum of x times x. Okay? I'm just expanding this. I'm getting rid of the square, just expanding it. If we go to this second portion of the sum of squares, what we do in that case is we get the sum of all the x's and then square that. If I expand that, it's sum of all the x's times sum of all the x's. Everybody with me? I'm just expanding this out, okay? And the reason I'm doing that is because this is sum of squares, right? Squaring here, sum of squares. The sum of products now is really interesting because what we're going to do is we're going to just replace one of these x's with a y. So instead of the sum of x times y, sum of x times x, we're going to do the sum of x times y, okay? And we can do this if we want. It's usually written like this. Okay. Then over here, I'm going to do the same thing. With one of these x's, I'm going to do a y. So this is, we're going to take the sum of all the x's, we're going to multiply it by the sum of all the y's and make sure that we divide by n in this case. Okay? So it's really of the same form as the sum of squares, but it is, we're replacing y's there, okay? So let's go back to our data, and when you do the computations here, I'm going to have you do computations for the final, okay? I have my x values, I have my y values, but what I need to do to get this right here, okay? I need to do x times y, we'll get that value. X times y, we'll get that value. X times y, we'll get that value, okay? And so, what we have now, and I'm going to give you guys a minute, you should probably do this yourself, so why don't you pause the video for right now. Why don't you pause the video and go through and do your x times y's, okay? So go through and do that, because I want you to do it so you get the hang of it, right? So pause the tape, go through and get those numbers, and then you can start the video again, and I'll show you what to do from there, okay? So go ahead and pause. Okay, so we're back. So I have my x times y values. So now what I need to do here, let's look at the formula. Let's get my sum of squares for x. That is, I'm going to get the sum of squares for this. Let's get my sum of squares for y. I'll do that here, okay? So once again, pause the video. Let's see if you're going to get the same answers as what I have. So we're going to get the sum of squares for x, sum of squares for y. Okay, we're going to need to get this. This would be the sum of the x times y values, right? So let's do that. Let's do that. You can pause the tape here. Okay, so we're back. So the sum of x times y is 321.8. I hope you got that. 321.8. Okay, and let me see my, I gotta see my sum of squares for x and y. What did you guys get? What did you guys get here? Oh, I don't have my sum of squares for x and y. Let's go back here. Let's go, let's do this. I have my sum of the x's is 149, right? So this is, let's go over here. Sum of squares for x. 149 squared divided by 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then my sum of the x squared values is 3943. So let's see if we can do that. 149 squared divided by 9. Okay, so this is 1476.22. Is that what we got? $1476.22. Okay, let me just check that again. 149 squared divided by 9 equals 244, excuse me, 2466.78. 2466.78. So it should be 1476.22. Okay. Sum of squares for y is, let's get this, 77.32. Everybody with me? And then we're going to do 25 squared divided by 9. Okay? So 25 squared divided by 9. 25 squared divided by 9. So that's 69.44. Okay? $7.88. Let me just check that. Okay. 25 squared divided by 9. 69.44. $7.88. Okay. So we have this value. We have this value. I'll go to my Pearsons R. Okay. Keep your wits about you. Keep your wits about you. Okay. So sum of squares for x, 1476.22. 1476.22 times 7.88. Take the square root. Okay. R is equal to. Now I need to get this value. Okay. I have the sum of the x times y. I have the sum of the x times y, 321.80. Now I need the sum of all the x's. This means sum of all the x's, right? The sum of all the x's is 149. What is the sum for all the y's? 25. Okay. The n is where some people make a mistake here. It's the number of pairs, or the number of people that responded to your survey, or the number of points in your graph, in your scatter plot. So that's 9 as well. Okay? Everybody with me here? This is the sum of all my x times y values. Once you get this, then you get the sum of the x times y, 321.8. This is the sum of the x's, the sum for the x's, okay? This is not the sum of squares, it's just the sum of the x values, 149, sum of the y values, 25, so we're going to multiply that together, okay? And let's do that, 149 times 25 equals 3725 divided by 9, okay? So this is 321.8 minus 413.88, okay? So 321.8 minus 413.88. So that's minus, this is my sum of products, minus 92.08. Okay? Everybody with me? Now, sum of squares can never be negative, right? Sum of squares can never be negative because you're always squaring those numbers. Plus, it's a measure of variability. So it's either 0 variability, which doesn't happen, or some positive number. Unlike the sum of squares can never be negative. Unlike the sum of squares, the sum of products can be negative. It can be negative. And in this case it is. And here's the conceptual part, folks. Here's the conceptual part. If you have a negative slope in your lines, in your points here, if there's a negative slope, if the relationship looks like this, right? The variables are changing in opposite directions, then your R value will be negative. Okay? Your R value will be negative. Since these can't be negative, the sum of squares, if you have a negative slope in your scatter plot, then the sum of products will be negative. Okay? If you have a negative slope, the sum of products will be negative. So at least that's a good sign because I'm looking at the data, I see that there's a negative slope, and I get a sum of products number that is negative. So that's good. And so let's finish the computations here. 1476.22 times 7.88 equals, it's a big number, 11,632.61. But I'm going to take the square root of that, and so that is on the bottom 107.85, on the top negative 92.08. For an R value of negative, let's do this, 92.08 divided by 107.85 equals, so we have an R value of 0.85. and that's negative, okay? An R value of 0.85. That's our Pearson's R in this case. For these data where we're looking at the relationship between alcohol intake and GPA, we have a Pearson's R value of negative 0.85, okay? And the R value is called the correlation coefficient. That's what R tells you. Now, guess what we're going to do? Guess what we're going to do with that value? What do you think we're going to do? We have a calculated R value. And so what are we going to do with that? Well, we're going to look up a critical R value. We're going to look up a critical R value, and we're going to compare the two. And if our calculated R value is larger than the critical R value, then we're going to say this is a statistically significant correlation. That means there's something going on for reals. Okay? So let's go back to our graph. Okay, so what do we want to say here? So the observed R value is negative 0.85. Okay, let's look at critical R value. We're going to look that up in the table, and let me see what table it is from the book. It's back in the appendices, like the other tables, and it is. So this is table B6. Now let's keep our wits about us, okay? There's a little bit of a funkiness here with our critical value because the degrees of freedom for a Pearson's R is the number of points in your graph minus 2 rather than minus 1. Okay, remember before we were doing minus 1 for our degrees of freedom. For Pearson's R, it's minus 2 for the degrees of freedom. And that is because when we were doing Ttest, we were looking at the mean and the standard deviation. Okay? So it was one-dimensional. It was 1 point mean and standard deviation, right? In this case, what we're doing is two-dimensional. It's on the XY axis, XY plane, right? So it's two-dimensional. We're really looking for the best fit straight line here, okay? And I'm going to try to make this two-dimensional. And there's variability around that line. But it's two dimensions. And in fact, Pearson's R value is related to how close these points are to a perfectly straight line. And we'll talk about that in the next video, okay? And how many points does it take to make a straight line? How many points does it make to take a straight line? How many points does it take to make a straight line? 2 points, right? If we only had 2 points in this graph, it would always make a perfect straight line. But these points tell you that no, all the data are not on that straight line. So the degrees of freedom are n minus 2. The n that we're talking about here, please pay attention, take notes, okay? The n that we're talking about here is the number of points in your graph, or the number of pairs, right? The number of people that responded to your survey. So there was 9 people. So the critical T here is for 7 degrees of freedom. 9 minus 2. Okay, everybody with me? 7 degrees of freedom. because it's the number of points in your scatter plot minus 2 instead of minus 1. The reason for that is because we have 2 dimensions, not just 1. So let's look at the table. On the left side, everybody with me? Degrees of freedom. And I mean, you can see it right from the table, too. It's almost like a cheat sheet, right? Degrees of freedom, n minus 2. You just have to remember that n it refers to the number of points in your graph. So 7 degrees of freedom. And I'm going to do a two-tailed test. That's what we've been doing, right? 2 tails in the curve. 2 tails, 0.05. Everybody with me? 7 degrees of freedom. I'm going to look across, and oh goodness, our critical R value is 0.666. Oh boy. And the critical value, it's not going to tell you negative or positive because it's whether it's negative or positive, this is the numerical value that we have to be larger than to say there's a significant correlation. So I'm looking at my observed R value, okay? Looking at my observed R value, I compare it to the critical, and I say, yes, there's a statistically significant correlation here. What does that mean? It means that as we see people with higher alcohol intake, that's associated with lower GPA. Okay, that there's something is going on here more than just by chance. That's what a significant correlation tells me. It tells me that the people that are reporting higher alcohol intake generally report lower GPA. The people that report lower alcohol intake generally report higher GPA. There's a negative slope here, and that's what the negative tells you. I always tell people when I'm looking at a correlation coefficient, when I'm looking at a Pearson's R, there's actually 2 pieces of information that gives me. The sign tells me whether it's a positive correlation or a negative correlation, and the value tells me the strength of that correlation. Okay, the sign tells me the slope. In this case, if I didn't have a negative R value, I'd know I made a mistake because I can see that there's a negative slope here. If the data were going this way, that would be a positive slope, and the R value would be positive. Okay, so the sign tells me the direction of the correlation. By that I mean whether it's a positive slope or a negative slope. See, you didn't think you were ever going to have to know that again, right? But you do. And then the value tells me how close these points are to a straight line. They need to be at least this close for us to say there's a significant correlation. In this case, we do have a significant correlation. Okay? And so I think that we're out of time for this video because I had you guys do some of those calculations. Just to summarize, right? The question that we're asking here is different than what we were asking with a t-test. A t-test allows us to say, is this mean different from this mean, right? Analysis of variance. Is this mean different from this mean, different from this mean, right? But we're asking a different question. We're asking a quite different question here for correlation. I'm asking whether these 2 variables are related in a systematic fashion. As one goes up, does the other tend to go up? Or as one goes up, does the other tend to go down? Okay? We're looking at the relationship between these 2 variables, not a difference. Okay, that's very important. And so when I'm asking that question, I'm going to do a Pearson's R value. This should be review. This should be review. Don't forget to take that square root. Okay, that's a huge mistake people often forget. So the only new computation that we have today is the sum of products. But you're going to get the recipe, so just follow the recipe. First step when you do a sum of products is to get this column, okay? We have the x, we have the y, we can get the sum of squares for the x's, we get the sum of squares for the y. Here's my new column, okay? This is x times y, so that goes here. And then this is the sum of all the x values here, multiplied by the sum of all the y values. Sum of all the x values was 149 in this case. Sum of all the y's was 25. Divide by n. N is the number of pairs or the number of points in your graph. Okay? So this was jam-packed. In the next video, we'll talk a little bit more about the R values and what they mean. And we'll go on from there and probably do another example, and then really talk about how you interpret these data, because that's the most important part. Okay, so hope you're all well. We're getting close to the end, folks. So stay with it. We need to persevere for just another 2 weeks, and then we'll see what happens after that, okay? So take care, be good, and all that stuff.